A warm good evening, class. In the last video, we have seen some glimpses about arc welding. Now we will directly switch over to the next part, which is known as the next parts of terms. The first one is filler metal. So here, this filler metal is like a cement that joins us to bricks as way. This filler metal is the metal which is used to add in the welded pool, where it is going to uh, hold two metals together upon solidification, right? So in the other way, we can say this metal is added to the welded pool, where the one thing about filler metal is that the filler metal comes into the picture when the electrode is not consumed. Okay, so that way the filler metal comes into the picture. So this thin material sometimes welded by melting two base materials together, right? So the next one is we are going to see nozzle. Okay, so in nozzle, right? For example, if we take MIG welding, okay, metal inert gas welding, and TIG welding, which is tungsten inert gas welding, which we see in the later part, you can see in these types of welding, here the shielding gases is a separate shielding gas comes into the picture by having the cylinder, like inert gases are kept in a cylinder. So for example, we have taken for tungsten inert gas welding, we are taking argon as the shield, inert gas. So here this argon should be purged towards the welded area through some means. So here it is a nozzle which looks like a shower, like the center part has a bigger hole, and we have side the around parts has the smaller holes, where the smaller holes are combined together in a small tube like format, and this is fixed to the inert gas cylinder. Okay, once this inert gas cylinder is opened with some pressure, so while welding, if we press the nozzle handle or some like a punch like thing, if you press it while welding, okay, while the welding is happening, this nozzles get opened, so the inert gas, just shielding gas, is purged over the welding area in order to avoid the outer atmospheric air touches the welding area, and also to have a proper weld. Okay, the term next what we are going to see is penetration, right? So for example, if we take two weld plates like this, okay, other weld plate, there is some fairing surfaces, okay, or the welding surface, the weld area. Okay, for example, if you are taking a very thick material, okay, for example, if you take about 10 mm thickness material, okay, or 15 mm thickness material, we are going to create a V notch, which I'll show it later. Okay, we have a very V notch. Okay, in order to make the material, in order to have a good weld, so while making this V notch, we'll make this weld material or the filler material to reach the center of the metal. So this center, what we see here is, this is the penetration. Okay, for example, okay, in the other way I'll say, for example, if you say, if you have a plate, okay, yes, butt welding, so mild steel plate, you are going to use a mild steel electrode to and SMAW welding process to make the weld over it. Okay, so while welding at a particular temperature, you can see on a particular arc power, you can see this while welding, due to that heat, this filler metal or the electrode material will get filled up in the fairing surface or welded surface, and it gets penetrated inside. So this is known as penetration, or otherwise known as the depth from the top region of a material while the fusion joining happens. Okay, so the next term what you are going to see is shielding gas. Okay, when shielding gas comes into the picture, you can say here the shielding gas is nothing but the inert gas. Okay, we cannot use other gases, which because these inert gases will not react on any time. Okay, so for example, you can say, if I'm using carbon, if I'm using oxygen or hydrogen, which are gases which helps to flame, okay, which I am using towards while doing the welding, we can have more number of heat, but the proper welding cannot be done. Okay, so the other way, we cannot avoid the other atmospheric contaminations touching the weld pool. So at that area, at that point junction, we can see, if you are using shielding gas, which are inert gases like argon, helium, here these gases will form a shielding atmosphere, as like we are wearing a gloves over hand. So this will form a shielding shielding atmosphere, shielding area, so that the outer atmospheric contaminations will not touch the weld pool. So this helps to form a good welding, good weld or quality weld over a material. Okay, we'll see the next rest of the parts in the upcoming video. Thank you.